let's get this party started. So today we're graphing trig functions. Everybody's got a calculator. Here's what we're going to do. Grab your calculators. Break out your calculadors. Turn them on. Make sure that your calculator is in degree mode. Everybody's pretty much should be in degree mode. Okay? Then, we're going to graph sine first. We're going to graph sine first. Now, type in sine x. The next thing that you have to do after you type in sine x is you're going to have to adjust the window. Raise your hand if you've had trouble with windows before and understanding them. Yeah? Here's the easiest way to explain the window is the following. Left, right, how much each hash is worth. Down, up, how much each hash is worth. Do you understand? Hash marker? A hash marker is like each one of those dashes. Notches. So let's talk about this. What's the leftmost x can be?
0.
That's what you do. And what's the rightmost it could be? Good. So that's 0, 360. And then every time you graph these, every single time, I want the hash markers for the x's to be worth 90. Because that'll separate things by quadrant. The first hash marker is the first quadrant, 0 to 90. The second hash marker will be 90 to 180. That's the second quadrant. Okay, the y min. The y min. So that's up and down. So when you're on the unit circle, how low can you go? Nah. Yeah, down to -1. And how high can you go? Up to 1. I love that song. Whenever they break that out, I start dancing. And there you go. There's sine. Now, you don't have to graph that entire thing. You're going to have to graph 5 specific points. Here, 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 and here. And I've labeled them for you. How did I label them? Look, starts here, goes up to here, goes down to here, goes all the way down here, and over there. And you're going to draw something that looks like a sideways S. There you go. And that's one full sine graph. It's got to go up and down like that. One full sine graph. So now we're up for cosine. Just take your calculator. It's going to be the same thing, right? Hit the y equals button. Type in cosine x. Hit graph. And look what cosine looks like. How would you describe that? A U. Sine and cosine are intimately related. Looks like a parabola type. Nope, there's 5 dots. 1, 2, 3, 4, 5. So we're going to have 1, 2, 3, 4, 5. And I want it to look U-shaped like that. That's what a cosine graph looks like. Bless you. Let's do this. I'm going to teach you how to manipulate the graphs a little bit. How to make them bigger, faster, move them up and down. Yeah, bigger, faster, better, bigger, faster, stronger. Move them up and down. I don't know. Anyways, you get the point. Copy this down. We're going to mess with A, B, and C and see how the graphs turn out when we sub in numbers for A, B, and C. All right, let's play. Let's play, let's play, let's play. So which one do you want to mess with, sine or cosine? Let's mess with the sine curve. So here's what I want you to do. I want you to type in sine x. You got that? And I also want to do this. Go all the way to the left, and I want you to hit enter, and I want you to graph it with a big bold line like this, because this is going to be like our traditional sine graph. And then I'm going to show you what subbing numbers in for each one of the things does to it. So there's our original. Now, go back into this screen. Go down 1 line. What number do you want to put in for A? No. A 1's already there. How about like 4? Or 3? Okay, let's go with 3. Let's go with 3. 3 sine x. Now, according to what I wrote down on the screen behind you, what does subbing a 3 do? Changes its size. It changes its amplitude, as we're going to speak of, its ability to go up and down. And so by subbing a 3 in there, what we've really done is instead of the radius on the unit circle being 1, it's now going to be 3. So how high up does it go? And how low does it go? 3. So go back to our window. Which one adjusts up and down this? The y's adjust up and down this. So the y min is going to have to be at least -3. Maybe we want to give it a little bit of a bump. Sure, let's make it -5, just so we can see the whole graph. And the y max is going to be 5. And now let's see. There's our original, our like razor phone, if you will. Up. There's our droid. You know what I'm talking about? It's new. Oh, I made it bold so that you could see how the original, how subbing numbers in changes it. So now, putting a number in front adjusts its height. Go back into the y equals screen. Now we're going to sub a number in over here. What number do you want to sub in over here? Let's change its speed. Let's make it 8. But you got to put an x there. Okay, don't just sub in an 8. It's got to be 8x. And watch what it does. So there's our original in bold. And then, boom. Look at it. There's going to be 8 sine graphs between 0 and 360. Go. Absolutely. Yes. Exactly. And on top of that, so this is putting a number in where we just put it in that B spot is known as changing the frequency. Okay? Frequency, we talked earlier about practical applications of this stuff. When you change the frequency, look at how much information can be conveyed with that wave versus the original one. Okay? All right. And finally now, let's throw a number on the end. Do you want it to be +1? +1 or -1? What do you think adding 1 at the end does? It's going to shift it up. So now, look, the original sine graph starts at 0. What's this one going to start at? At 1. Yeah, and you see it. It's been shifted up by 1. It's a little off. See that? It looks like it starts at 2, but I'm pretty sure, I'll guarantee you it starts at 1. I can take away the original. Watch. Let me delete this one, and then I'll show you. Look at where it starts at. Really? I mean, here. To prove to you that it does start at 1, I'm going to zoom in. Where do you want me to zoom in at? I will, whoops, since you don't believe me, right? Because this is more fun. Oh, that's 1, buddy. That's 1. I win. I win. Yeah. Okay. Just letting you know that I won. Record. The very last thing that we're going to learn about today is what we will continue on with tomorrow, and that's amplitude, frequency, and period. Amplitude. The absolute value of that first number is how high or low it goes, or it can reach. B, the number is known as the frequency. It's how many of the graphs you will see, how many complete cycles you'll see between 0 and 360, or 0 and 2 pi if you're in radians. And finally, period. Sometimes you want to know how long it takes to complete one cycle. That's what period is. Like, how long is the period in this class? 47 minutes. It's the same thing. How long it takes to complete one class or one cycle. That's all we have for today.